Good afternoon. This is SER321, Principles of Distributed Software Systems. And today we're going to be talking about Unit 2, which is compiling and debugging from the command line. So if you go to the website or to the Blackboard site, you'll find under the detailed schedule, Unit 2, which is C, C++, and Java, and using bash command line to compile them. So I want to spend some time actually showing you some resources in case you want to brush up on Java or C and C++, because from the detailed schedule there are a couple of links to what I consider to be really good tutorials for both of those languages. Since the beginning of Java, first Sun and then Oracle has supported a Java tutorial that is loaded with examples. So if you haven't used it before, I think it's well worth taking a look at. So if you have any problems with the language, there's lots of examples there, and that's a very good thing to use as the basis for looking at different things. And you'll see as we go through the semester, there are aspects of Java. For example, there's a swing tutorial. There's a tutorial on RMI. I'll refer to these later on in different units. There is a great guide. This is from Nick Parlante, who is a faculty member at Stanford. This is probably 10 or 15 years old, but it's an excellent guide to the C programming language. So even if you've taken a course on C++ and feel like you know C++, chances are very good that going through this tutorial will give you a much better feeling and understanding of the C programming language. Why is that important? Well, the reality is that C++ is kind of an extension of C. So a lot of the stuff that you do in C++ is really based upon C. So that is an excellent resource I encourage you to take a look at. And then there is also a tutorial on C++ that is available from one of the common websites, cplus.com. So there's a link here to the PDF for it, and if you actually go to the website, there are links to the source code that's used within this tutorial, and it covers lots of different stuff in C++. So if you're interested in that, by all means take a look at that as well. And then last time in Unit 1, I also pointed you to, where was it? Oh, it was out of the command line tools. We're going to take a look at that too. There is another link to the wiki page for C++, and I highly recommend that you take a look at that as well. Let me just kind of blur everybody's eyes here for a minute, but if I go back up to the top of this thing under the reference section. So these are the class notes for Unit 1 and Unit 2 on command line editing, compiling. Actually, we're going to use it for Unit 3 as well. But under the references part of this is the link to Unix programming tools for C++, the GNU C compiler, and then there was also, where was it? Yeah, I don't see it right now. The wiki page. Look up the wiki page for C++. I thought I had it in here, but maybe I don't. It's also very good. And actually, even if you're an experienced C++ programmer, going through the wiki page actually will fortify your understandings of objects as opposed to primitive data. It'll also fortify in your mind the difference between automatic storage and heap-based storage and the management of those kinds of different areas of storage. Okay, so today we're going to take a look at compilation from the command line. And I know that in CST200, for example, you probably did command line compilation for Java, but I want to talk about it. Hopefully you'll find it useful. We're going to take a look at a couple of different aspects of it, because as we go through this semester, we're going to be working in more detail with Java's command line for both compiling and executing. So there are, well, there it is right there. There are some example programs for you to download. You don't have to worry about the second one. It's Objective C. If you're interested in iOS, then that's a good thing to look at. But you see, in fact, there's an example program in Java. These are both, actually, they're based upon. There was a, is it the C++? Maybe it was an Objective C tutorial that I used to use Objective C in this class. And there was an Objective C tutorial that used a very simple fraction example in Objective C. So I developed the equivalent. I mean, they're just really simple program, simple class, and a simple program just to show you how to define a class, how to instantiate an instance of a class, and use it. In doing that in both Java and C++. The goal is more working with the command line than anything else. Okay, so let's start out with Java, and I want to say a few things about Java. First of all semester long you're going to see the Java compiler command invoked, sometimes with a class path, sometimes also with a destination. The syntax is all available on the set of documentation for the Java development kit. And we'll take a look at that, particularly the API documentation as we go forward. But it details what all the different options are for Java C. So sometimes when we use the Java compile command, we want to have a class path that includes some already compiled things. And so we need to create a class path for that. So lots of times it'll be Java C dash class path and then a path. It looks just like the home path environment variable, or the path environment variable that we looked at last time in our look at Linux. And other times, in fact, we don't need to specify a class path because what we're compiling only depends upon the class libraries available within Java. And then in invoking Java, right, in executing Java, we have a Java command. And then we have to provide a class path. So if we haven't defined an environment variable called class path, and I don't think it's defined by default, let's go and take a look. I don't think I have it defined on either one of my systems, but we'll take a look here and find out. Echo $class path, and actually just doing the tab. You can see I don't have anything defined as class path, so in fact we have to define it or give it as part of the command for doing compilation. Okay, so contrast with C++, right? So we're going to do C++ with the GNU C compiler, G++. When we compile a C++ program. In fact, here's a sample command line for compiling this example program. It's not the one that we're going to be using when we're debugging, but nevertheless, it will compile. In this case, it's all defined. Well, there is a class implementation for fraction in fraction.cpp and a main.cpp. So those two implementation files go into the creation of a fraction program. All right, so with the G++ compiler, we compile and we also link our program to create an executable. All right, so there is no equivalent in C++. There's no equivalent to the Java command. And that's actually kind of an important distinction between Java and C++. C++ and C and Objective C and the other C-based languages, there are actually several other ones as well, they don't compile to what's called bytecode. They compile to object code, meaning that the underlying operating system knows directly how to execute the code that gets produced by the GNU C compiler. And there have been all kinds of controversies about the execution efficiency of Java relative to C, C++. But suffice it to say that in fact C++ is at a different level, and when you compile it, and link it, it actually produces a loadable image, as it's called, executable image, that does not have to have a runtime, well, it does have a runtime environment, but it's not nearly the same runtime environment as with Java. So, for example, when you invoke the Java command, there are about 10,000 different classes that literally have to be loaded into the runtime environment in order to start executing your Java program. And that's not the case with a C or C++ program. Of course, depends upon how you execute it. If you're using the .NET framework, they take C and C++ and package it all together and execute it the exact same way that all of the other .NET family of languages execute. All right, so let's take a look at these examples. So our goals today are to look at, actually to get through essentially this slide, which is to do command line compilation, to take a little bit of a look at what gets produced in each of those cases, and to use the debugger. All right, so I'm going to switch over to the Linux environment so we can do it in that context. And let's go through and look at each of these programs. So I've already downloaded them. There are links in the PDF file that I just showed you to CPP fraction and Java fraction. And let me get to the directory where those things are located. It's in my examples directory. Maybe I'll boost this up the size of it a little bit. So LL is a long listing. It's an abbreviation. If you go in and edit your .bashrc file in your home directory, there is a commented out definition of LL. It means nothing more than ls space -l. It's a shorthand that does the exact same thing. So when I do ll star.jar, it shows me all the jar files that are in the current directory. And in particular, CPP fraction and Java fraction are the two that we're concerned with. So after you've downloaded them, place them into your examples directory, and then go to that directory, and jar is one of the Java programs. A jar file, a .jar file, stands for Java Archive, JJava, AR archive. And the Java archive uses the open source zip, the same compression technique or algorithm that is used with zip. So there is a tool that you get when you download the JDK, Java Development Kit, called jar, and it will allow you to create and or extract Java archives. So jar -xf, you can actually leave the, well, let's do it the xvf. xvf, that stands for extract, verify, and then a file name has to follow it. So let's do java fraction.jar. Notice that I typed J only, and then I hit the tab. All right, so I don't type that fast. I typed one letter of the name java fraction.jar, of the file name java fraction.jar. And now if I hit enter, what's going to happen is this zip file is going to be extracted, and it's going to create for me a new folder called Java Fraction, and within that folder there's a build.xml, a lib directory, and a readme.txt, and then a source subdirectory. So let's change to that directory, cd Java Fraction. And that time I had to type JA because in fact there's two files that begin with J. And now I'm in the Java Fraction directory, and if I do a listing of it, LL, there's a build.xml. We're going to talk about that next time with ant. There's a lib directory, a readme.txt, and a source directory. And this, the lib directory, oh, we don't need to worry about the lib directory today. In the source directory is Java Fraction, or fraction.java. So it's a single class, and within that class there is a main. So from the main directory, I can, let's do this. Let's do it the way we're going to do it with all the rest of our projects. mkdir classes. And now, so that made a new folder called classes in this Java fraction directory. And now let's do Java C-D space classes and source Java, or just fraction, excuse me, fraction.java. So this is the Java compile command. So it's going to go and read in whatever Java files I send to it, and it's going to convert them into .class files. Those .class files are the form that can be loaded into the Java runtime environment, the Java command. All right, so there's the compiler working. And now in the classes directory, LL classes, you see that there is a fraction.class. So doing the Java C command created fraction.class. And now I can execute that by Java-class path classes. All right, so I tell it, here's where you have to look for classes, and then just the name of the class, fraction. All right, and it executes the program. So now let's play just a little bit about it so you understand packaging a little bit. This is my favorite editor, Emacs, and Emacs, I don't know, I just really messed up things here. Here we go. Emacs, let me boost up the font size. There we go, so you can see a little bit better. At the beginning of it, how come I'm in fraction.cpp? It's the wrong one. Example / Java fraction source fraction.java. Okay, so this is a Java program, and it defines a class called fraction. And notice that the import is java.io.star. Don't tell Richard or AJ that I use .star. Good practice says you list each of the different classes that you're going to be importing, and I haven't done that in this one. Some examples I do, and other examples I don't. I'm not even sure that I use java.io in here, but it doesn't matter. Okay, so this class has two instance variables, a numerator instance and a denominator instance variable, private int, numerator and denominator, and it has a constructor called fraction. And what the constructor does is set the numerator and the denominator to 0. And there is a print method. It's probably more common to have a two-string method, but this actually prints it out. Numerator plus, right, so it says numerator / denominator, prints out the fraction in its current form. It's set numerator and set denominator, and then the main program. And then the main program does nothing more than create a new fraction object. It calls the set numerator method, the set denominator method, and then it prints out frac.print, right? So about as simple of a program as you can get, maybe a little bit more complex than Hello World, but not a lot. Okay, so now let's do this, because you probably haven't played with packaging yet. At the very beginning of a Java class file, it's very common to package it. So we can say package SER321 dot math, semicolon. So this says that I'm going to create a path, or excuse me, packages are segmented. And there is a direct relationship between the segments in the name of a package and in directories within a folder. So now let's go back, and I'm going to do what I call cleaning, rm classes star. So now if I do a directory of classes, I don't have the class file anymore. But I have changed the Java file. So now let me go back and so now here's the other thing, some of the shortcuts. I didn't give you any of the shortcuts. If I do up arrow or hold down the Control and the P keys at the same time in the bash command line, it will sequence back through the previous commands that I have executed. All right, so if I keep going back, I go back to my Java C command and then hit enter. All right, so I don't have to retype Java C again. So now LL classes, and there's no more fraction.class in here. All right, so it is a packaged class, meaning that in order to specify that class, I have to give it a fully specified name of the package. So if I tried to go back to my Java command and execute it, it won't work. Can't find it. Right? This is one of the most frustrating. Could not find or load the main class fraction. So what do I have to do now? It's in this class's directory. Let's find out exactly where it is, just to show you. Remember I said that it's in package SER321.math. So if I do LL classes SER321 and math, right, notice that those directories got created for me. So now within the classes folder, there is a new folder called SER321, and within SER321 is a folder called math, and within the math folder is the fraction.class. So in fact, class files, the relationship between the compiler and the underlying operating system, is that by convention, when it compiles and creates a class file, it packages it in the same directory structure as is expressed in the package. In order to use it, in order to invoke this program, I say java-cp classes, and then fully specify 321.math.fraction. Right? I don't have to have the .class at the end because it knows that it better be a .class file. If it's not a .class file, it's not going to be able to execute it. All right, so now it runs just fine. Okay, so now if I had two different compilation units, two different files, two different .java files, if they happen to be in different packages, then I'd have to include an import. So I could say import SER321.math. And now fraction. Now that's probably not going to work because this is the definition of fraction and you can't hardly import something that hasn't been defined yet. But let's just, for the fun of it, see what the compiler says to that. Yeah, said, okay, I don't care. I know you're doing it. So if I was in a different, if a different program wanted to use this fraction and that program was in a different class, then it would have to include this import. So reading between the lines, what I just said is that any source file or any class within the same package as another class automatically has visibility to that other class. All right, so if I have a fraction and a complex, if they're both inside of SER321.math, then they can see each other. But if in fact one of them is in SER321.math and the other one is in SER321.imaginary, then in fact you'd have to use an import for it. Okay, so the other thing I wanted to mention is that I could take care of all of this with a class path. So I could say set environment variable class path equals, and then I'll use quotes, classes, / classes, quote. And now if I say echo $class path, it didn't work. Declare, different systems are different, -export, class path equals. And there you see that my environment variable, so declare -x class path, or another syntax that's common is export class path equals. Either one of those works. And actually in some systems set works too, but obviously Debian Linux is not one of those. Okay, so now I can say Java and then SER321.math.fraction. And it executes it. Why does it execute it? Because I've set it looks when the Java command starts up, it gets access to all of the currently defined environment variables. So it looks for an environment variable called class path, and it says, okay, so no matter what you type in the command line, I'm also going to search this class path that it's already given me. So it automatically looks in the /classes directory, and in that classes directory, it's going to find SER321.math.fraction. So I didn't have to do my .class path. Just by the way, for information, the next time I start up LX terminal, class path will not be defined. It's local to this instance of bash. If I wanted it defined all the time to be that way, I would have to actually put it into the .bashrc file. All right, so I could do something like cat greater than .bashrc, and then copy and paste this declare -x. All right, so what that would do would be to, if I hit return here, copy and paste the declare, it actually end up at the end of my .bashrc file, but I don't want to do that. Okay, so now let's take a look at, there is in this thing, so now we know how to compile it and execute it. Emacs, I don't have to start up another Emacs, let's just do the README. So here's a README file, and it tells you about the Java debugger. And it's the very first thing here. So here's some example commands. There is a command line Java debugger called the JDB. So here's a good example of how to make it work. So let's go back and forth. Actually, let's get them so they're both showing here. Come back here. So if I go and do Java C dash dspace classes and then dash G for debugging support, source fraction.java. I actually, if we went back and took a look at it, this class file should be bigger, but it should have support in it for debugging. And now I can, instead of using the Java command to start it up, I can do jdb dash class path is classes, and then SER321. I don't know why I put that package in there right away, because now I have to type it all the way. Math.fraction. So now I've got an interactive debugger running, and what it's going to do is control the execution of the program. It's only going to execute the program the way that I want it to. So I can put in breakpoints. If you've seen an IDE, it's much, much easier to do it in an IDE. Stop in fraction.main. I'm just going to do the exact same thing that's in the readme.txt file. Stop in fraction.fraction. What's fraction.fraction? I mean, you know what fraction.main is, right? Because there's a static method main in the fraction class. So I can say stop in class name dot, and then the next thing is a method. So fraction.fraction is the first fraction refers to the class fraction, and the second fraction in this fraction.fraction, the second fraction is the constructor fraction, all right? So I can also do a stop in fraction.setNumerator. So I want to set some breakpoints before I do run, so I make sure that the thing gets stopped someplace. So now if I do run, it'll start execution. And let's see, what happened here? I don't know. Set uncaught, java.language.throwable, set deferred uncaught. So I'm guessing there must have been some error return in my sets that I didn't stop in fraction.main, initializing JDB. It will be set after class is loaded. Well, it looks like I've done something wrong. Let's go back to this guy. You know what? I'll bet it's because I packaged it. Let's get rid of the packaging. Oops, wrong one. Oh, duh. So I got rid of it, and now let's do RM classes star. So we'll do it again, recompile it, and let's see if it works. I think what happened was because I packaged it, I actually have to fully specify the fraction. So it should have said stop in SER321.math.fraction. That's too much typing. So let's go back here. We should, yeah. That made a difference. Okay, so now we are at line 58, and I think it's list. It's not print. Oh, sorry, that's the GNU debugger instead of the Java one. So now I can actually print. Let's do continue. We'll get into, so where we are right now is in the main, and this is line 58. That should correspond with line 58 in the program. 758, right there. So in the main program, after the try block, there is fraction. Fract is a new fraction, right? So this is the first executable statement in the main. And it says that, I know that it's line 58 because I don't have line numbers on the left-hand side, but in Emacs it shows you what line you're on, and I'm pointing to it right now in the Emacs editor. So I'm at line 58, and if I do a continue, I've got a breakpoint set at set numerator, so that's the next thing that happens. So breakpoint hit at set numerator, and this is line 39. So if I go back up to the set numerator, I'm sitting at line 39, where the numerator is getting set to the input argument. So now I can actually step. So continue says go on till you get to the next breakpoint. Step says to execute the next instruction, meaning the entire Java instruction. So step should take us to line 40, and line 40 should be that guy right there, the return statement. But before we return, instead of setting the numerator to, I think it was set to 1, let's do set numerator equals 6. Print, let's see, is it print? Yeah, print numerator. All right, so now let's just go ahead and continue, and you can see, you got to type it in right, Tim. And now instead of printing out 6 divided by 3, it prints out 1 divided by 3. So the idea is that with the debugger, the most common thing to do is to set breakpoints, then to examine local storage. Generally, it's instance variables within an instance of a class, and even maybe make changes to them. And even when it's not a primitive, you can actually examine other things, objects that are instance variables within a given class, make changes to them and so forth using the Java debugger. And this is actually the basis for doing in an IDE, an integrated development environment, for doing debugging in an integrated development environment as well. Okay, so there's an example of Java. Let's go do the exact same thing in C++. So back to the examples directory, jar xf, cpp, fraction.jar. So previously I did xvf, which prints out everything that's in it. xf says just extract the following file, and since I know that it's created a directory for me, cd cxx cpp fraction, and make clean. And let's go and do the README for this one. So in this file, or let's just go back here, Control X1. Let's go back to its directory. In the source directory, I now have three files. The programming idiom in C++ for creating a class is not to put it all into a single file. And the same thing is true for the main program. So we're in Java, we created the class in the file fraction.java, and we included the static main. That's a very nice thing to do when it's convenient for a simple program. But the reality with very complex programs is it doesn't work that way. And thus the dichotomy or the separation between the use interface to a class and the implementation of the class. All right, so I intentionally pointed to different places. When we create a class in C++, we create that class so that some other part of the program can use it. And we don't necessarily want the other part of the program to know about the details of the implementation. We just want them to know the methods or what's available in order to use it. Well, Java has a mechanism called interface that allows you to do that. So I don't mean to say you can't do the same thing in Java. You can, but in the way that that's typically done in C++ is by creating a .h file, or in the case of C++, it's usually .hpp, although it's C++ kind of loose, sometimes it's hxx and cxx instead of cpp, but they all mean C++. So what we expect to find in fraction.hpp is only the stuff we would need to know if we want to use an object of the fraction class. And that's all that's here. It's declaration stuff. So here is, actually it has to have the numerator and denominator. I don't remember, I can probably declare them to be outside of the public area so that they're private, but it has to be able to process the HPP and know allocation size. So these are almost always included in the HPP file. This tells me that there is a constructor for the fraction that doesn't take any arguments. It also tells me there's this thing, it's called a destructor. The tilde before fraction means when it's time to clean up a fraction, I'm done with using an instance of the fraction class. Then in fact, usually it's a system that calls it. It calls tilde fraction, which deinitializes, deallocates, and gets rid of the fraction. So if there's any cleanup that one has to do as a part of getting rid of an instance of a class, you know, maybe it's tied to a database and you have to push stuff out to the database or what have you, then in fact that would be done in the deallocator. We also have a set numerator and a get numerator, a set denominator, a get denominator, and a print method. The same capability that's provided in the Java. All right. So compare and contrast. Now in the top half of Emacs is the interface, if you will, the H file. And in the bottom, let's do fraction.cpp. And fraction.cpp brings in, includes, is like the C++ version of an import. It brings in different headers. In this case, CMath, standardlib.h is a C lib, IOStream is a C++ lib. And notice that it also includes fraction.hpp, so it knows that this is a part of the fraction class. It knows what the fraction class is. So we define now in the class fraction is the fraction constructor, and the constructor sets the numerator to 0 and the denominator to 1. Can't divide by 0. There's the destructor, and all it does is just set stuff to 0. Set numerator, get numerator, set denominator, get denominator. The point is, all of the methods that are defined in the H class by their signature only, meaning this thing that ends with a semicolon, so I know a method exists, I being a user of fraction, know that the method exists and that I can call it. In the CPP class, in the implementation, it has to provide the details of how it actually is implemented. So what does it do? In this case, it's very simple, right? Set numerator sets the instance variable numerator, lowercase numerator, to have a value of the input argument n. And get numerator returns that numerator, and so forth, right? It's a simple class. But the point is that in the CPP file is are the implementation details, and the HPP file is the interface to it. Okay, so that's C++ very quickly. Actually, the other component of this program is the main. And the main, notice that the main doesn't import or include fraction.cpp, it includes fraction.hpp. So it doesn't have to have access to the code generated by the main, really only has to have access to the header file. All right, and the main is very simple. Fraction star afract means that afract is a pointer to a fraction object, is a new fraction object. So it calls a constructor, allocates, calls a constructor to initialize it, and now afract arrow print is just like Java afract.print. Afract arrow set numerator to 1, set denominator to 3, does the exact same thing as the Java does. All right, so here is the C++ syntax for doing that. Now let's go ahead and actually take a look. We'll do it straight from the README file, so you can replicate it. Now, in order to be able to use the debugger, we have to keep around what are called the .o files, and the .o files are generated. They are what gets generated by doing the compile only. So to retain the .o files, we use separate compile commands. The first with the -c switch, compile only, and the second with the link. We also use a -G switch for generating debugger information, and it's in the build script. So there's a file here. So here you can see them, and I'm just, instead of retyping them, Mr. Lazy, copy and paste. So let's go ahead and, so here's the -G-GGDB specifies that the debugger that's being used is the GNU debugger. So that allows it to generate some information that's specific to the GNU debugger. So what happened now is that, as I mentioned, I think on the in the last session, compiling for C++ is a two-step process. One is to compile, and the next is to link. To generate an image that can be executed. If I do an LL now, give me a long listing, notice that I have a fraction.o and also a main.o. All right, so these are it's called .o stands for object files. Those are the input to the linker in order to actually create it. So now let's do the second command, and that comes also from the script. The way that we created the .o's is by doing the -C. Right, so here -C says compile only. And the next one, -G GNU debugger, take the main.o and the fraction.o and add to it the library standard C++ library. Actually, that should be the default, although actually in order on Mac OS X, it's not necessarily the default. And then -O is the executable image. This -O says the output is the executable program fraction. So let's go ahead and execute that. And the linker runs very quickly. So now when I do an LL, you'll see that there's an additional file, and it's worth taking a look at, once anyway. Notice that this file is colored green, and the reason that it's colored green is because there are these X's over here in the permissions, which says that, okay, so if you look at the main.o, there's no X there. X means executable. So this is literally an executable image, meaning that I can execute it. Why is the build script executable? Because in fact it's a bash shell program. So I can do /build script and it'll execute as well. So now I could start my fraction, /fraction. I don't have to call something like a Java. So it is a directly executable one. Fraction, before I did the set numerator, set denominator, is 0/1. And then after doing the set numerator and set denominator, a little bit different than in the Java, is 1/3. So let's run it with the GNU debugger. And again, we'll just kind of follow the script right out of the README. So GDB fraction. Oh, that's strange. So actually, you should be in the process of going through this and creating your VirtualBox. There is a set of programs that are called package manager programs that control what is installed on a machine. I'm not sure why, which GDB, right? I'm spelling that right, GNU debugger. So apt-get sudo is, for execution of this command, make me the super user. Apt cache search quote GDB. This tells me all the packages that are available to be installed that have GDB in them. So the whole message to me is that GDB by default comes with, how come this? I'm just really amazed that it didn't come in with G++. Well, I'll tell you the answer to it next time, but right now, just so that we see that it works. And let me boost up the size of this so you can see it. So what I've got here is a bash in OS X and /build script is executable. All right, so now you can see I've just done, it looks the exact same thing as it is in the Linux. I'll find out what I need to do to get, what you need to do, we need to do to get GDB to run on our Linux implementation. But now you can see here's fraction.o. The executable fraction and main.o, and then this thing actually has fraction.dsym. This is OS X, GDB. fraction. And there's the GNU debugger. So now we can go back here and follow the, let's just do, we're going to do switching back and forth here. Be a pain. So what we're going to do is, let's see, we've got to set the break in the main, and then steps, run, step list, fract. Let's see if we can get them both the same time. There we go. So now we've got a breakpoint set in the main, do a run, and we get to that breakpoint, and actually this one actually is a little bit better because it prints out the line that we're at. Doesn't it list? Yeah. So in this one it actually lists the current context when you do list, so it shows me the source file, and you can see that I'm currently at line 41. 41 is fraction star a fract. All right, so I guess the script that I had was to step and then print. So that takes us into the constructor, print numerator. So in the constructor, we're now in the instance of a fraction, and the numerator has a value of 0. If we do a step, and now print numerator, let's see, it's still a value of 0. What is our step list? So if I do list now, we are at CPP 29, which is numerator gets set to 0, of course. Step, denominator equals 1. So now let's set, I think it's set, yeah, set numerator ERATOR equals 5. And now let's just do run. No, don't do that. It should be continue. There we go. So now you can see it says the fraction initially, after doing the constructor, instead of setting it to 0, I set it to 5. So in the first printout, it gave me 5 over 1. All right, so there's an example of using the GNU debugger in order to debug a C++ program. Okay, so let's go back to where we are here. Is there anything else about C++? We talked about the fact that it creates an object, a loadable image in C++, as compared to Java's bytecode.class file. And we also talked about the commands and the class path, the use of class path. Oh, and that's all we need to talk about for today. So let's leave it at that. And in the next unit, what we're going to talk about is the use of the build tools ant and make. And actually, after doing that, we will have covered enough material for you to have handed in the first assignment. Although I have to tell you, the first assignment, let's just go back to that. The first assignment is, most of the work in the first assignment is to get your Debian, or VirtualBox Debian up and running with a Java compiler and the C++ compiler. All right, most of the C++ stuff and Java stuff that I've gone through, I'm hoping is review. But if it's not, that's okay. And the big thing is to be able to produce the compilation, use the bash command line processor to make directories, and also to compile and execute both Java and C++ from the command line. Okay, so that's enough for today. That's Unit 2, and next time we'll take a look at build tools. Thanks very much.